So you see my screen, Kishan?
Yes, very well.
Great. Uh, Thank you and welcome for this presentation, multi-factor approach for flaky test detection and automated root cause analysis. And I am Azeem Ahmad presenting, and this work is done with Kishan Sandal, Ula Lifer, and our master student Zishang. Okay, agenda is the first mistake I noticed myself. We'll talk about what we have done. I'll take a few minutes to talk about what we have done for Flaky test until now. It started 1 year ago. And the current problem statement we are trying to solve through the detector, the tool, the solution, how the tool works, what is the architecture, and then I'll demo the tool. But during my presentation, I have some screenshots that you can have a look before we move to a demo. And then what we plan to do during the next sprint after this, and what you need, and if maybe we'll raise a discussion, what you need or how can the tool be modified to your customer, to your needs, and then question and answers. We started, let me take a pen. So this started with a survey a year and a half ago, where we tried to analyze where the company stands when it comes to flaky test. And we noticed that most of the integration and system testing is the place where they find test flakiness. And they also have a review process. All the companies have a review process, but still the most of them have 5 to 10% flaky test in their test suite. This 5% could be less, but if you have 5,000 or 10,000 test cases, then this amount is a bit bigger. And when we ask them that how much time do they spend to how much resolving test flakiness, so we notice most take some hours, one takes several days, and then few takes up to the day. So this was, we were trying to find out that whether this is the real problem in the software side companies and not. We also talked to them what mechanism do they use to determine if the test case is flaky or not, and then all of them rerun the test cases. And it's not with our software center companies, it's, I would say, all the companies. The most adopted and common approach is to rerun the test cases to find out if they're flaky or not. Some inspect text execution logs to find out. Uh, when they find flaky test, what do they do? Either they create a bug report, either they open the test case to investigate, or some disable the test case, which I think is not a good idea because, in my humble opinion, the test case might be checking a bug, and then if you disable that test case, the bug might slip to the product. Unfortunately, none of the company label the flaky test so that either we can have a look or they can in future come back to it, either as a flaky test, repeat, ignore, rerun. So this is the issue we also found during the last year because we did not have any data from the company that have flaky tests. So we have to go to the open source to work with our flaky test detector. They told us that asynchronous wait, configuration, and the dependency issues are the common problem. I/O operation, GUI, test order dependency, and time, clock time. These were the major reasons that they believe causes test flakiness in their company. We also talked about some factors that can either decrease test flakiness or increase test flakiness. All these slides that I'm presenting can be found here, and we submitted this paper in a journal. It's under review. So these are the factors in the company's opinion that increase test flakiness or decrease test flakiness. For example, if you have a robust test cases, you will most probably decrease test flakiness. But if you have that unstable CI or Jenkins, then it will increase. So if you want to read more, you can definitely refer back to it. We have a machine learning method. This paper is also accepted in the workshop here, published. It's just presented on 1st December. So we tried to evaluate the predictive power of the test smell flaky test. And we use the machine learning algorithm on the contents of the Flaky test. We thought that similar to spam and no spam email, where you look at the content of the email and you can define whether this email is spam or not, we can look at the content of the Flaky test and we can define whether this test is flaky or not. But we find out that looking at the content of the test case only is not fair or gives you more information, because in this paper we find out that the flakiness also depends not only the test case but a test class code, maybe tier up and tier down setup, operating system, whether it is running 64-bit, 32-bit, Mac, external libraries. Are you using some commercial libraries, any library that is available in the Java, or a hardware product? So we noticed that using a machine learning algorithm, only a content of a test case won't help us, and only the 4 predictors are the strong predictors. All these predictors are the weak predictor and does not help you using a machine learning on test cases. A similar study was did with Pinto et al. With Java test cases. We did this study with Python test cases. They had a good recall and good precision, but in our case, we had a bad recall. So if you want to read, you can go ahead and you can, of course, read about it. Now, the current problem which we tried to address during this sprint is solving Toby problem. So Toby had execute test cases as a tester, and he has noticed some test cases are failing, and he hasn't changed the code. Everything was fine yesterday. Now he wonders why test cases are failing. The only thing he does is rerun the test cases. And of course, when he reruns the test cases 100 times or 200 times, it's costly because it takes the computing power and it shares the testing budget. At the start of the project, you dedicate some budget to your testing activities. And if you have to rerun the test cases 100, 200 times, time to time, then it's going to share your testing budget. Toby also noticed that it's unreliable because he doesn't know, should I run 50 times? Should I rerun test cases 80 times? Or should I rerun 100 times? Maybe during those 100 times, you may not achieve those conditions that made the test case flaky at the first time. So it's very unreliable. And even after the 100 rerunning, the 100 times rerunning the test cases, which is costly and reliable, you still don't know why that test case is flaky. It's just you want to know during the 100 time if the test case changes outcome from pass to fail or fail to pass, it is flaky. You still have to dig deep to find out why this test case is flaky. And then I believe that our tool can come handy in these situations. What our tool does. Then the Bobby comes. Bobby believes that number of test smells in a test case makes a difference. And this is proven in academia, in the literature, that if you have specific smells, for example, you are using random function without seed, you are trying to access input without checking if it exists or not, maybe the other smells. If you have test smells, then the test case might be flaky, and you need to look into those test smells, how to handle them, maybe having an antidote for it. This is the one factor that Bobby believes makes a difference when it comes to find flaky tests. Another factor Bobby believed that if the failed test case did not execute on the code changes. So you change one part of a code, but the failed test case did not execute on those changes. It executed on the changes, on the code base that have not been changed. Then why these test cases are flaky? So Bobby also believed that if my test case failed on unrelated code changes, then this is most probably be flaky. Bobby also believed that if I maintain a test case history over a period, when the test case changes its outcome from pass to fail, fail to pass, without any modification in the code base, I can mark that case, that I can keep an eye on that test case. Because if this test case is failing and it has a history of changing its outcome, okay, this is not a real failure, it is a flaky test. Since Bobby is a strong believer he also believes that test case size makes a difference. This is not a proven factor, it is a perceived factor identified in our study that is under review in the paper, that the complex test cases makes increase the test flakiness. So we're trying to find in this tool if it's really the case or not. Now, since we have 4 factors, how do we find a final score? How do we know whether this test case is flaky or not flaky? So we use a machine learning algorithm. KNN algorithm, we train our algorithm on open source data with the labeled test, flaky and not flaky. And then we find that do the failed test cases have the characteristics similar to the flaky one. And at the end, using those 4 factors, we find whether this test case is flaky or not. We have some extended functionality in the tool. For example, if you want to see the output of a single factor, F1, F2, F3, F4, you can do that. If you want to see the final output, whether this test case is flaky or not, you can do that. If you want to find the flaky test in the last failed build, you can do that. If you want to find a flaky test 3 months ago, you can enter a specific build ID, you can get that information on your test case. The output mostly either is in graphs, images, or CSV files so that you can read them later. Now, the algorithm, other than the factors, the algorithm that's implemented is that if the test case 1 failed and its previous state was passed, you just check the traceback coverage, which is the factor 2, I think, yeah. Whether the failed test case executed on the changed code or unrelated code. And then you mark, if it executed on the change code, then it's a real failure. Then it's the case of the non-flaky. If it did not execute on the unrelated code changes, then it's flaky. You change it, or you do anything, or maybe you rerun it, or you do some changes, whatever you do the second execution. And if at that time it failed, then you use multiple factor, which includes traceback, test smells, its history, and the size. And then you mark the tool mark whether it is flaky and non-flaky. How does the tool work? It takes the Python test cases as it is, because we need to scan, we need to parse to find test smells in all the test cases, and to know whether the test case executed on the code changes, we need to have a traceback history. Either you are maintaining your project on Travis where there is a history available, or you can upload a JSON file. We have provided a specific format. So if you are using Jenkins or other CI pipeline, you can create a JSON file and then you can give this to the tool. The tool maintain a database and at the end give you a CSV file. Now the technical constraints that we have is it only works at this moment with the Python. So the test smell information is only available with the Python. But if you have other language, but you can generate a JSON format of the build history, all this, which test cases are failing and which test cases are executing on which code, then you can use this tool without the test smell. So either you use a build log from Travis or you create your own JSON format. Now, coming to the output before I go to the demo, one of the results you see from the tool is this diagram that can be generated. If you run this diagram, it gives you a high level information. For example, 234 test cases in your test repository is flaky due to a traceback information. 374 are non-flaky. Machine learning algorithm marked 447 test cases as flaky. And missing information, if we have a missing information like a test smell is missing or history is missing, we marked it as a missing and a 44. So this gives you the overall information, a diagram. But if you want to go detail, which test cases in which build ID were flaky, you can get this CSV file or a terminal output. It will tell you the build ID. It will tell you the method name. It will tell you whether it is flaky or not flaky, and what is the detection method. is whether it's a traceback coverage or a multi-factor detection method. It can give you a number of smells if you have flaky frequency, which means how many number of time it has changed its outcome in the past, and the number of lines uncommented code and the path. So this will give you detailed information with all the builds in that you have until now. If you want to know a little bit more high level information, it can tell you about the test smell. How many test cases are without the test smells? What is the number of smells? So 18 test cases have one number of smell, 4 test cases are 2, and distribution of the test smell. So you have IO test smell, network, randomness, and testing. These test smell, if there is a study on the internet that investigate test smells in Python language. So we got this category from them. If you want to have a detail of the test smell in all the test cases, you can run the tool and it can tell you that this test case have 6 test smell, and that is why it is repeated 6 times, and mostly are network, URL, online number 47. And this is the path. This test case have 5 test smell related to training, 4 and 13, 19, 25, 16. So if you want to know a detail which type of test smell are present in which test cases, the tool will help you. If you want to know the test smell, earlier when I was here, I was talking about journal. Here, if you look at Flaky, this is the final outcome. You don't want to look into number of test smell, the history, although it's present here, but this is the final outcome. But if you want to dig deep in a single test case related to the test smell, its history, or traceback changes, you can use this tool. So in a specific test case, it will tell you the information of the specific test case, what test smells are there, what type, and what location. Now, if you want to know whether the failed test case executed on the code changes or not, you can find it during the latest build, if only in a failed test case, not the past test cases, or by giving a specific build. And the output will look like this, that this is the failed test cases in this build ID, and the status is false. False means did not cover code changes, and the path. Test case history. If you want to know which is the notorious test case I have, you can see that this test case have changed its outcome 33 times during, in my database is a 3000 days. It's a big database I'm maintaining from the JSON. So you can clearly see that which of the test cases have a history of changing its outcome. And this test case only changes outcome 1 time. And it also gives you a build ID, in which build it changed its outcome when no code have been introduced. Test case size, it's a very simple metric you can have from any metric program. If the test case is bigger, complex, more number of lines of code, we believe it's flaky, because the idea that we investigated in the previous studies that you should keep it simple. Just test one thing or 2 things in one test case. So, and then you can have a less test flakiness. Now, what screens I have shown, I can give you a demo, but it will be the same of code that I showed you. But the tool is available here. I just need to make smaller changes. This is the tool. We made it publicly available, Apache 2.0, but I'll soon share it with everyone. But since this is recording, you can have an address here. Now I will demo the tool. So it's a command line. So let's see if we want to see the high level image I showed with the detector. So we do this. So we have the Python 3 show.py. I mean, we are trying to get it properly with a GUI. Perhaps we'll have a bachelor student that can add good colors or a proper GUI into this tool. But at this moment, it uses terminal. Or I'm not sure if you want to add these instruction into a Jenkins as a post build instruction and how it works. So you say results, and then you wait. Then you can see that it generated that figure. Of course, I have a JSON file before in the database, and if you read a README file on the tool, you will know how to download a JSON file and how to run the command that will read the JSON file automatically and put it into a database. This is the file I already explained. You can generate it, and the same information was generated as a CSV file and in the terminal. If you want to know which test cases are flaky in my test suite repository, you can run the command python show.py dash dash type flaky, and you will see the list here. So it's telling you the whole list here, also a CSV file, that this is the test case, this is the build ID, this is the test case name, and whether it is flaky or not, trace back coverage. This is all the information that I just presented you here. Here. So if you want to know with specific build ID, okay, give me the flaky test in the specific build, you can run show.py type result ID. So it's always the same thing. You're just changing the last parameter, and this is the build ID, or you can give any build ID. So I don't know if I can reduce the size and align the table properly so you can, yeah. So you can see that in this build ID, 4 tests were failing. One was not flaky because the traceback, the test case failed on the changes. It executed on the changes. This was flaky because it did not execute on the code changes. It has nothing to do with the code changes. And the method was traceback coverage, not multi-factor. So we decided whether the test case is flaky or not in the first line of defense and then path. If you want to change the build, you can of course enter other and give the build ID. If you want to know a test smell detail on the higher level, that okay, how many test smells are present in my test case, or what type of test smells are there, you can generate this figure that I already showed you. You can also have this diagram here. So out of all your test suite, 1, 2, 3, how many? Yeah, few test cases have these numbers of test smell. Same way, if you want to know the detail, okay, I know that test Lex or this one has 6 number of smell, but what type of smells are there and what is the line number? Then you can run this command with the smell details and it will give you all the information that this test has 6 network on this line of code, on this line of code, or in this line of code. Open a file without close it. Resource operation without checking existence. 4 in range. So these are the different test smell that can give indication to the tester, okay, I need to have a look. If you want to know something, for example, I want to know a specific test case. For example, tester made a new test case and maybe he's the beginner one and he wants to know how things are going with my new test case. He can take the test case name, which in this case is this, and this one. Of course, when you execute a new build, you have to run a new command so that your database history is updated properly. If you want to know the show test case history, so this is the test case history that I showed you, that this test case has changed until now in the whole history, all the database I have, maybe it could be 6 month old or a 1 year old, 6 times changed its outcome when no changes were introduced. So this means this whenever this test case failed, it's more likely to be flaky. So with the information of the number of test smells or its history or traceback coverage, I can mark it more flaky, or at least I can raise a discussion with other people that, okay, this is the reason that this test case is flaky, while you are saying that this is not flaky. So it gives you a little bit a root cause analysis of your flaky test. Coming back to this, the demo that I already explained, I haven't checked it, but I believe that this demo you can integrate it with your Jenkins CI, and once the build is failed, it can generate some CSV files that you can have a look. It saves time. Why should we use it? You don't need to rerun test cases 100 times or 200 times. Your test case failed. You use this tool and it tells you whether it is flaky or not using a machine learning algorithm, and it provides detailed information about each test cases. It saves test budget, reduce computing power. And if you're having a conflict whether this test case is flaky or not, should we dig deep? Should we look into a test smell perspective? Should we look at the test case history? Maybe we need to remove it. So it helps in resolving conflict, this tool, rather than rerunning it. What we plan to do during the next sprint is tool evaluation. We will see if industry wants to use it, or one person wants to use it, and then we can see whether it addresses people's need, or do we need a modification in a GUI or in some sort of any other factor, or we need to remove a factor. So if you really think that this tool can help you, please let me know and we can use it maybe 1 day, 2 days, or for a longer period of time, and we can see its real value, if it really helps you, or do we need a modification, which we are open for this. It's now, since we have this and we are a step ahead than flaky test detection, now we are going for a root cause analysis. Okay, people say that this test case could be flaky, but we need more information, more detailed information, why this is flaky. So our plan next sprint is to come with some more mature technique that can tell you, okay, this test case is flaky because of 1, 2, 3, 4, 5. And it doesn't just tell you the factor, maybe it gives you at what environment it's changed its outcome, or at what input parameters, or what. But the initial idea that I'm pasting here is about parsing log or rerunning it. So I have a net idea, but it depends on the interest of the companies. But the idea is to have a more mature technique for only root cause analysis and leave the detection part. Or maybe if you don't have a Python test cases, yeah, this tool can still help you with test case history and traceback coverage. But if we can assist you, if you have test case in other language, to see if you can also look at the test smell. Now, discussion. If you have any question about it, or what do you think, I'll take question. And
I got a question from in a private message asking for how good is the tool when it comes to recall and precision.
Yeah, so when we conduct our, when it comes to a relationship between traceback and flakiness, a single attribute, we got 95% accuracy and more than 85% precision. But when it comes to the other factors like size or a test smell, we only reach to something with 80% or 80%, but it's good. I'll show the experiment. I'll show the results later if we have a chance. But the number is more than 80 or 90.
Mm-hmm.
Any question if anyone has? Or do they think that they have faced any of this factor in their setting?
I mean, the dangerous question, is this relevant at all?
I think it's really relevant. I mean, people want to run test cases that are fairly stable. We don't want to be stuck debugging the test case.
Thank you.
So I think it's really relevant point, the flakiness.
And what about the factors that we currently take into account? Do you feel we are missing something?
No, I feel more that I'm missing something, that I want to go back and have a look at my test cases.
Yeah.
But no, I don't. I don't know. It's one of the causes. Does that cover the test environment?
Yeah, that's the factor we find out our machine learning that it's important. And when I said in a more mature technique, what environment it's failing. So that's the goal of the next sprint, that really environment makes a difference. And people really want to know specific details, maybe on what input, what parameter, what environment, rather than that test case failed. So something that gives a proper message, but that proper message is related to a flakiness, and that comes to this sprint. But if you have any data, maybe any log that you would like to share with us, it will give us something where to start from, where to look for.